Good morning. I'd like to greet to Professor Kumurul. So today we would like to present the topic about the anti-static bag for electronic packaging. So this is our group members, Hidayah, Muhammad Afiq, Faris Iqmal, myself and Ahmad Izzuddin. Okay, so firstly I would like to present regarding the material selection strategy. It's under the process of translation. Firstly, we need to find out the function, which is to wrap the electronic devices. The constraint is transparent, flexible, heat resistant to maximize the performance, able to be recycled. Next is the objective, which is to minimize the cost. The free variable is choices of material. So next is the screening process. So we choose the the material which are PET, PE and PLA. So we have compared the design requirement, which is categorized under the price, transparency, melting point, yield strength, tensile strength and density. So these are the range of the material based on the design requirement. Okay, next is the metric selection, where you would like to find the metric selection for each of the material based on the comparison format using the formula. So for example, the price we had compared, we had found out the PET is 6.78, PE having 5.77 and PLA is 7.56, whereas the transparency is material 1, PET have transparent, PE is transparent and PLA is transparent, so three of them are transparent. Next is the melting point, 238.5 for PET, 128.5 for PE and 168.5 for PLA. Next is the yield strength, which is 59.4 for PET, 23.45 for PE and 54 for PLA. Next one is the tensile strength, which is for PET is 60.35, for PE is 32.75 and for PLA is 54. Lastly is the density. For the PET is 1345, for the PE is 949.5 and the PLA is 1230. So after we have done the metric selection, we will go through the process of ranking. So based on the ranking process, we have find out the material for PET having the price value of 7, whereas the PE having 10 and PLA having 5. Next is the transparency. PET have a 10. PET scored 10 for transparency, PE 10 and PLA 10. For the melting point, PET has got 10, PE is 5 and PLA is 7. Next is the yield strength, PET has got 10, PE 4, PLA 9. For the tensile strength, PET has 10, PE 4 and PLA is 8. Density is 10, 7 and 9. The total for PET is 57, total for PE is 40 and total for PLA is 48. So based on the ranking, PET at the first place, PE third place and the PLA is second place. So the documentation for material. So based on the polyethylene terephthalate, a material which is inert and extremely resistant to water-based solution. Besides that, it also has a high melting point, yield strength, tensile strength and density compared to the polyethylene and polylactic. Therefore, polyethylene terephthalate material are selected to produce the antistatic wrapping plastic.
Okay, there is 4 elements in the process requirements. So first one is function, constraints, objective and free variable. So for the function, it's used for removing a thin film of a plastic material such as PET. So there are 7 attributes for the constraints, which is material. We use polyethylene terephthalate. Shape is non-circular. Process characteristics we decide to use in primary shaping. While the minimum section thickness is 0.2 mm thick, and tolerances 0.5 mm to 1 mm, surface roughness less than 1 micrometer, and the batch size is For the objective, we want it to minimize the cost, and the free variable is choice of process. So this is the graph which non-circular preservative versus mass range. We found that there are 5 processes which it can perform the non-circular prism shape. So the 5 processes are planaring, grinding, injection molding, milling, and polymer extrusion. However, we only choose one, which is polymer extrusion, as it meets the requirements, 7 attributes that we need. So for the planaring, we cannot use it as the process because it uses PVC to produce a thin flat shape, while we use it PET. While grinding and milling, we cannot use it because it is not a primary shaping process. For the injection molding, it is high cost production, so we don't want to use it because our objective is to minimize the cost. So the polymer extrusion is the best process because based on the attributes, it is the non-material process which can use PET to produce thin-shape packaging within the specification at lower cost.
So next I want to explain about the extrusion process for PET. First, the plastic material enter through the feed throat and meets the rotating screw. Then the plastic film manufacturing process start with melting down the plastic called resin and until they become molten. The molten plastic is pushed in the extruder through a circular die to form a continuous tube of plastic called the bubble. So next, the bubble is inflated with the air to the desired shape and diameter vertically up to the tower, giving it time to cool down before it is flattened into its lay flat down width. So next, the thickness of the film is controlled by the speed at which it is pulled from the die. The width of the film is controlled to the amount of air inserted in the bubble. Then a bag machine will seal and perforate the film to form varying length of bags on roll. Lastly, the film will be cut and separated for individual cut.
Okay, for the flow chart of the process to make this PET antistatic bag is starting from the raw material. Then from the raw material we will put the material into the mixer, and the mixer will blow into the extruder, and then from the extruder it will go to the cooling process, and from the cooling process it will go to the next is extruder mode, and after that from extruder mode it will start to the shaping system, and from the shaping system will go to expanding unit, and after that the expanding unit, then it will go to the front off unit, and after that is winding unit, and will start the last process for the packaging.
Got. So next is the effect of parameter. There are 5 process parameter. The first one is melting temperature of plastic, which is in this case is PET. It has the range. It must be in the range of 195 degrees Celsius until 220 degrees Celsius. So the second one speed of the screw. The third one is extrusion pressure required for the extrusion. So the fourth one is type of die used, and the fifth one is the cooling medium. So if the process does not meet the required parameter, the product will not meet the specific function.
Okay, next for the testing of this product, this is anti-static bag. The anti-static bag can be tested using these two methods. That is, the first one is perform a resistance test on the bag film to less than 1 times 10 power of 11 ohms at 100 volts using two 5-pound electrodes and mega ohm meter per ESD S11.31 to 1994 and ESD DS20.20 to 1998. The second method is to perform a turbocharge test yielding static decay of less than or equal to 140 milliseconds per FTMS 101C method 4046. For the quality control is taken to ensure the quality of the product. So the quality control is the EMC testing to inspect the quality of the anti-static bag before release to the market. EMC test can be grouped into two categories. The first one is immunity testing and the second one is emission testing. Immunity testing is to measure how a device will react when exposed to electromagnetic noise and other disturbance. The purpose of this test is to gain a reasonable assurance that the device will operate as intended when used within its expected operating environment. While for the emission testing is the measure of the amount of electromagnetic noise generated by a device during normal operation. The purpose of this test is to ensure that any emission from the device are below the relevant limits defined for that type of device. This in turn provides a reasonable assurance that the device will not cause harmful interference to other devices operating within its expected operating environment. Next, for the defect of this product is the anti-static bag is not resistant to electrostatic discharge. If something else with a charge touches the bag, such as person hand, its charge will easily transfer through the bag and its content. So for the countermeasure of the defect is, to counter the defect, layers of polyester and aluminum are added to the polyethylene terephthalate. This will make the anti-static bag resistant to electrostatic discharge, and this type of bag is also called as shielding bag.
As a conclusion, polyethylene terephthalate is used in application ranging from for film, tube, plastic, pipe, laminate, and others. In several markets, it is usually used in electrical component, automotive, and packaging. So most of plastic material are electrical insulated and have the ability to support high static build-up. And static is produced by charge separation caused by the movement of one material over another. And static build-up can result in issues including first, increase the handling and contamination issue during transport, storage, and packaging. And second is dust attraction affecting both appearance and performance of plastic product. Third is risk of electrostatic discharge that will damage electronic components. And lastly is risk of electrical discharge causing shock to employees and even fire and explosion. This is the disadvantage of static. So by using this anti-static bag, it will anti-static additive are added to the plastic to reduce or eliminate all the static build-up. And last is discuss